In this video, we're going to be looking at two different graphing polynomials. The first one is going to be in factored form, and the second one is going to be in standard form. So there's a lot of different things that we need to know. It's everything we talked about before. So the first I'm going to start with is determining my leading coefficient and my degree. My degree, once again, is the number of linear factors I have. So I have 1, 2, 3, but I have this one twice. So I actually have 1, 2, 3, 4. So my degree is 4. And then my leading coefficient, well, in factored form, we're just looking in the front. There's nothing here, so I'm going to go ahead and say my leading coefficient is positive. From our notes earlier, if my leading coefficient is positive, that means my right-hand side is going up. 4 is an even number, so that means my left-hand side is doing the same thing. I can write that in my notation as x goes to negative infinity, y is going up to infinity. As x goes to infinity, so the right, y is also going up to the right. This is also going to help me when I get to my graphing. I'm going to make sure that this matches. The next part is the zeros. So each of my factors, if I set it equal to 0, would give me its 0. So for the first one, I'm going to have negative 1. The second one is 2. And the last one is 4. I'm now going to look at their exponents to determine the multiplicity, determine how many times I have them. So here, this one just has an exponent of 1. This one has an exponent of 2. This one has an exponent of 1. So this is going to give me those behaviors when I actually try to sketch it. I can also put those numbers in. I'm going to have a 0 and negative 1. I'm going to try to kind of scale this, so 2 and 4. The last one that I want to talk about is the y-intercept. Because this is not in standard form, I don't have a constant. So instead, I'm going to plug in 0 for each of my x's. So 0 plus 1 times 0 minus 2 squared times 0 minus 4. So that becomes 1 times negative 2 squared times negative 4. That becomes 1 times positive 2 times negative 4. Sorry, I forgot to square my 2 there. Negative 2 squared is 4 times negative 4. And this is equal to negative 16. So my intercept's at 0, comma, negative 16. That's on the negative side of the y-intercept. I'm just going to choose something in the negative side of the y-axis and then go ahead and plug that down. So now I'm actually ready to start graphing. So notice the first thing I did was actually just put these coordinates, my intercepts, on the graph. There's no numbers here, so I just made sure that they're in the approximate correct place. So the negative x's, positive y's, negative y's. The next thing I always do is my end behavior. From my furthest zeros, I know that's where my end behavior is going to come from. So I'm just going to go slightly above those and draw the arrow of my end behavior. I know that if I do this correctly, I will connect those. I'm then ready to actually sketch it in, and I'm going to make sure that I follow my multiplicities. I know that at the 2, I'm going to have to touch my axis and turn around. At negative 1 and 4, I'm just going to go through normally. So I'm going to start at my far end. I'm going to come down to negative 1. Once the multiplicity says just to go through, so I'm going to do that. At some point, I have to turn around. I might actually turn around a little bit earlier so that I can hit this y-intercept. Now I'm approaching 2. Once again, 2 says to make sure that I hit the x-axis and then turn around. So I'm going to come up. I'm going to hit the x-axis and I'm going to turn around. Now I have to come back up here, so at some point I have to turn around. And these turnaround points, I'm just estimating. And I met that other end. Once again, where I turned around here, these turning points, when we're just doing a quick sketch of a polynomial, we're estimating where those are. If you had access to technology, you could find the exact locations of these turnaround points. And those of you guys who go on to take calculus will also learn how to find those turnaround points. But for now, we're just estimating. So this is what you need. You need to make sure your end behavior matches your degree and your leading coefficient. You need to make sure that you go through all of your zeros and only through your zeros. Don't cross the x-axis anywhere else. And make sure that you're following those multiplicity rules. So this one, it was given to us in factored form. But what happens when it's given to us in standard form? There's some information we can still find. The degree, now it's just my largest exponent. So my degree is 3. Its coefficient is my leading coefficient, so positive 1. I can use that to determine my end behavior. Because the leading coefficient is positive, my right-hand side is going up. Because my degree is odd, that means my left-hand side has to go in the opposite direction. So as x goes to negative infinity, y goes to negative infinity. So on the left, I'm going down. As x goes to infinity, y goes to infinity. So on the right, I'm going up. Now, the tricky part comes in finding my zeros. I need my linear factors in order to find my zeros. So that means I have to be able to factor this cubic. I notice that each of my terms has an x, so I'm going to start by factoring out that greatest common factor of x. That leaves me with x squared minus 3x minus 4. So I'm looking for the two numbers that multiply to give me negative 4, but add to give me negative 3. And those are negative 4 and positive 1. So that's going to factor 2. I'm going to keep my x, and then x minus 4, x plus 1. So taking my quadratic and factoring it out. Now, each of these can actually give me my zeros. At x, I have the 0, 0, 0. Negative 4 gives me the 0, 4, 0. And x plus 1 gives me the 0, negative 1, 0. I have each of these factors once, so their multiplicity is going to be 1. I'm going to go and put those on my graph. And then my y-intercept. Well, we said that when you're looking at it in standard form, it's your constant, so your number that doesn't have a variable. Well, looking here, I don't have a constant. So what that really means was that there was a plus 0 all along. And because there's a plus 0, that means my y-intercept is going to be at 0, 0. Another way to think about that is if this is ever one of your x-intercepts, it has to be your y-intercept as well. So now I have all the pieces to graph. I'm going to start with my end behavior. So once again, from my furthest right, it says I'm going up. From my furthest left, I'm going down. And then I'm going to connect. Each of these has a multiplicity of 1, so I'm just crossing through it. I'm going to come up. I'm going to hit negative 1, come through. I have to turn around to hit 0. And then at some point, I have to turn around to hit 4. Now, I did not actually go through 4, but that's okay because this is a quick sketch. So I can actually just move where my 4 is because I was sketching it. I want to show very specifically that that goes through at 4. And there you have it. This is how we can graph a polynomial, whether it is in factored form or it is in standard form.